Okay, here is a midpoint Riemann sum. Okay, this was number 3 on our quiz, or 1C on our quiz on Friday. Again, same function, x squared plus 2, but these are now midpoint Riemann sums. Again, the basic calculation, get used to doing it. So I'm going from 0 to 6. So 6 minus 0, that's a total 6 wide. I want 3 equal intervals. That means each one is 2 wide. Okay. And I'm going to draw a number line again, help me focus my thinking when I do my arithmetic on this thing. So I'm going from 0, 2 wide, 2, 4, 6. Now remember, a moment ago we were doing videos with left and right Riemann sums. So doing the left Riemann sum, I'm taking a look at the left edge of each rectangle, 0, 2, and 4. When I do the right-hand side, it's the right side, 2, 4, and 6. The midpoint, well, I'm taking the middle. So just draw a quick sketch of that. Here's an increasing function. So the left-hand Riemann sum touches like that, okay? Touches the left corner, upper left corner of the rectangle touches. The right-hand Riemann sum is like this. The upper right-hand corner of the rectangle touches, okay? And the midpoint, it's sort of much as the name implies. I'm going to draw a rectangle, and it touches right in the middle of the rectangle, the upper edge. Not the left-hand side, not the right-hand side, but the middle. Okay, so we call it a midpoint Riemann sum. So in this case, I'm going to be looking in between 0 and 2 is 1, in between 2 and 4 is 3, in between 4 and 6 is 5. Okay, so let me get rid of this. So the approximation this time now, again from 0 to 6 of x squared plus 2 dx is going to be approximately equal to, again, each one of these is 2 wide. The midpoint doesn't change that. I'm going to factor out that 2, and it's going to be f of 1 plus f of 3 plus f of 5. And again, I'm taking the function of the midpoint of each of these intervals, okay? And f of 1, so it's going to be 1 squared plus 2, so that's 1 plus 2. F of 3 is going to be 3 squared, or 9 plus 2. And 5 is going to be 5 squared, or 25 plus 2. Okay? And I add all that stuff up. And what am I going to get? I did a calculation before. I don't want to do it now. We add all those up, and it's going to be 82. Okay? And if you leave it like this with all numbers, that's fine. You cannot leave it right here. You've got to go down at least to show everything's just a number, but you don't have to actually go to the step of actually adding it up. All right, now over-underestimation for midpoint are trickier, okay? It's not a matter of increasing or decreasing, it's a matter of concavity. Here, I've got the sketch right here. The function we're looking at is x squared plus 2. It actually looks quite a bit like this. It's concave up. Remember, concave up means that f prime is increasing, okay? Now, I mean, on this side of the function, the derivative is negative, but importantly, it's becoming less and less negative. Right here, it's very steeply negative, a little less steep, a little less negative, much less negative, 0, slightly positive, more positive, more positive. So even though it's negative here, it's getting less negative. So it's increasing throughout this interval, and that's why it's concave up. Okay, now, the fact that it's increasing like this helps us visualize a little bit of why it's an over or underestimate. So it's concave up, and we're already saying this is going to be an underestimate. But let's look at why. Open this up a little bit. This curve here, this was the slope, now it's steeper. If the slope had stayed here, the curve would have gone over like this, and you would have had a large, a relatively significant portion of this rectangle above the curve, okay? But it didn't stay like that because the second derivative is positive, and the first derivative is getting steeper and steeper. So I'm exaggerating here with my little red line. But the point is, this thing didn't stay down here, it went way up here. And because it went up, this blue shaded area, this area between the curve and the top of this rectangle, is relatively large. Heck, if it hadn't gone up, it might not have been any area above. So that's a relatively large area above this rectangle. And if you look, this blue area above the rectangle is much greater than the little red area, sort of where the rectangle is above the curve. All right. A lot of the function is above this rectangle in this area. Okay. So this rectangle isn't tall enough. This estimate isn't great enough. This is an underestimate, and it's because it's a concave up. This is much less easily sort of done intuitively, but it's important to have some sense of how it's done, right? So I would have to go back up here and I would write, um, we just said what was is a underestimate, right? Underestimate. Whoops, I'll abbreviate here. Underestimate because it's a concave up function with midpoint Riemann sum. Okay. Again, you have to say all of these things. You got to say it's an underestimate, and you have to mention it's concave up, and you have to mention it because it's with a midpoint Riemann sum. There we go.